let's do that. All right, so these are the definitions that are relevant for 3.2. Now, what I want to do is I want to start the class off by asking a couple of questions. One, do you see any of these definitions here that you don't understand or you need some understanding with? And then the other is also about where we are so far. We did 3.1 homework. We did 3.1. We can also go back to make sure that you guys are okay with any content that we covered before, that it's just not gelling with you appropriately. Now, I heard somebody say yes. I think that was that you, Amika Williams?
Yes, it's the definition.
All right, the definition of which one?
Well, can you elaborate on bias estimator, please?
Yes, and let me tell you, bias estimator and unbiased estimator are probably the most challenging concepts to understand in this chapter. And I'll try to sit back and do that. Let me see if there's a visual first that I can use on here to help us use it. I don't see anything. All right. So let me give you an example of this. I want y'all to imagine that the GPA of everybody in this class is a 2.4. I think I've used this example a little bit before, right? The GPA for everybody in this class is a 2.4. 2.4 GPA for the class. That means we took everybody in this class, got their GPA, and your GPA is a 2.4, right? Now, I want y'all to sit back and think about this. Why in the world would we calculate the range? Why would we calculate the standard deviation, the variance, the mean, the mode, the median? Why would we do any of those things? Why are we doing them?
Is that like to see where everybody is at in the class? Like some people grades might be higher than other people's grades.
Yeah, you know what? You're on to it. The reason why we would calculate any of these measures, right, is so that we could learn a little something about the class. So we calculate the mean and we want to figure out what the average is. We calculate the mode, right? Because this is the issue. We had this issue with faculty evaluations. Faculty evaluations, the mean can hide a lot. Think about this. Faculty evaluations, you rate faculty on a scale of 1 to 5, right? The mean can hide a lot. A mean of 3.4 doesn't tell you that there's somebody who had a 0 in the class, right? And you can't go but so high because 5 is the cap. So we're learning a little bit of something about the data. That's the reason why we would do any one of these things, right? Now, the concept of a bias estimator and an unbiased estimator, I'm gonna go with the definition, but then I'm gonna try to help us understand what it means, right? Bias estimator, right? It's a sample statistic. That means we're gonna calculate it on the sample, not the whole population. The population is 2.4, GPA for us in this class, right? A bias estimator is when you take a sample. So we're gonna do the mean GPA, but we're only gonna do it on a sample. Let's pick 3 people from this Zoom right now and find out their GPA. That's a sample. When I calculate it on that sample, we call it a bias estimator if it does not tend to center around the value on the population, which means this. And now imagine we're talking about the mean. The population mean is 2.4. I wish I could just hold up the number 2.4. But when we calculate the mean on 3 random people, it's going to be somewhere around this 2.4, right? And the more samples we do, or the larger the sample we do, the closer it gets to 2.4. If we have a bias estimator, right? Actually, I think I messed up. I apologize. An unbiased estimator is one that the mean is 2.4 and we calculate it on 3 people, right? And the mean that we calculate on the sample is going to be real close to 2.4. The more we do it, these values are going to be real close to 2.4. Now, a bias estimator is a little different. A bias estimator means this, and let me take it away from the mean. Let's do range. We're going to get the range of test scores on the 3.1 math exam. We haven't even probably even taken that yet, right? But we got the range of the 3.1 math exam. So some people got like 100. That's the one person score. The lowest score we got is like a, let's say a 34%. Now, if I were to get 3 people in this class and ask those 3 people and calculate their range, right? As you can imagine, if we're only going to pick 3 out of the whole class as opposed to the entire class, that range isn't going to look anything like the range for the entire class. The range is going to be really weird. And that's what we call it by being a bias estimator, meaning that the range, if we were to calculate the range off the entire population, but then we do it off some samples that are within that population, it's not going to be close to that range. It's going to be all over the place. I could sit back there and calculate 3 people at random, and it might be the 3 best people, right? Now, that doesn't mean you're going to have a big range, because the 3 best people got an 89, a 94, and a 93. That's a really small range. We could pick some other people, and it might be in the middle somewhere. So a bias estimator is when you have a statistic that when you perform it on a small sample within that population, the values are not similar to if you calculate that same statistic on the population. And I think the range is a perfect example of that. I'm going to, you know what? I'm going to do an example with all of y'all right now. I want you to sit back and we're going to go in Excel. I want y'all to calculate the number of letters and put it in chat. Count the number of letters in your first name and put that number in chat. So I'm Chris, or I'm going to say Christopher. I think I have 11 letters in Christopher. So I will type in 11 in chat. All right, let me go in the chat, see the scores I got. I got 5. We got more than 5 people in class, so let's go. All right, 6, 5, 6, 7, 5, 6, 6. One more 6. Yeah, I'm 11. Then we got a 7. All right, so think about this. Let's do the range, right, for this sample. All the values we have, how do we calculate the range, people?
Add everything together?
Oop, nope, if we add everything together, we're going to get a value. Let's do this right here, sum. We get 53, that's if we add.
Are we taking like the person with the most letters in their name and then the person with the least amount of letters in their name and subtracting the 2 from each other?
Now, the only thing I don't like about what you did is
It was a
2
question.
things.
I'm sorry.
No, that's not the only thing, too. It's 2 things. One,
Okay.
you had it in the form of a question. The other is there's some statistical terminology that you try to do conveniently, right? Now, she thinks about the largest number letters and the smallest letters. What do we call them if we're a statistician?
Value.
All right, but so we're talking about what do we call the largest value? The definition of range calls it what? And I'll go back to the slide because that's what we're doing today. What's that right there? Y'all see that? Wait, do y'all not see that?
Maximum.
Okay, the maximum, and that's the largest value. What's the smallest value?
Minimum.
All right. So to calculate the range, we would take, what's our largest value?
11.
Subtracted by
5.
5. Right. That is our range. Right? Now, we're talking about what's a biased estimator and an unbiased estimator. I'm going to pick some of these numbers right random. And you know what? I want everybody in here to pick 3 of these numbers by random. right? I'm going to pick this one.
Do you want us to put it in the chat?
Yes, you can put your answer in the chat. I want you to pick the numbers you picked by random and then also what your range is. These are the three that I picked, but I want all of you to sit back and list them. And I'm going to list how I'm going to write them in the chat. So wait for me to type it in so we all can see it, how the format I want them to be. My value, would put my initials in there, CB. I did 6, 6, 5, and my range equals 1. All right, so now Reese, you put 3 in, but let's figure out what your range is. Okay, they're coming in, they're coming in. All right, Amika had 11, 5, and 6, just picked them, and her range was 6. All right, Latifa picked 5, 6, and 11, her range was 5. All right, now Reese, 7 and 11, her range is 4. Siani Goodman, hers is 1. You got to realize all of these ranges, right? They are different. You know, the largest range I think we have is from 5 to 11. I think that's 7, right? But these numbers are not being the same. We cannot be confident that if we pick any 3 random scores and calculate the range, right? Deja just did one right now. She found out a range of 2. There is no format. So these are what we call biased estimators. When we calculate the same statistic on a sample from within the population, those scores are not really going to be indicative. I can't sit back there and pick 3 of you, get the range, and be like, yeah, this is my range in my class. Can you imagine if I was a faculty member and my job is based on whether or not students like my class? And I pick 3 people out of the class and calculate the range. I'm hiding so much information from the people that need to know. Now, if I do range on the population, it tells you the whole story. But the range on a sample, it's a biased estimator. Now, I want to go back and look at some of these. We're going to talk about this. It's kind of jumping into the lecture a little bit, but I want to sit back and go over these and let you know which one of these are actually biased and then unbiased estimators, meaning that when you calculate them on a sample within that same population, those scores will either be unbiased, which means they're very close and they're a good indication of what's going on in the population, or if they're biased, which means that they're not an indication about what's going on in the population. The range we just showed you right here by now. Depending on the 3 that you pick, that range could be way off. So that is a biased estimator. Standard deviation. Standard deviation is referred to as a, actually, I feel like I don't want to go on and tell you that. The standard deviation, I think, is also a bias estimator, but it's in a different way. The reason why, because when you do the standard deviation on a sample, it's not like it's off because the scores can be different like the range, but the sample of the standard deviations from within that population, it's biased in a predictable manner. Now, we're not going to get into it, but a statistician could look at your standard deviation from a sample, if you do it several times, and since it's consistently biased, he would be able to sit back and predict what your real standard deviation is. So it's biased, but it's not chaotic. The range is biased and it's chaotic. It's all over the place. Standard deviation is biased, but there is a method to that bias. Still biased, but there's a method to that bias. Variance is the same exact way. It's when you sit back and calculate the variance, if you do it on a sample, not the entire population, it's not going to center around the value of the population, but it will be able to do so in a predictable manner. So that's what a biased estimator and an unbiased estimator really talks about. Some of the best unbiased estimators are the mean and the mode. the mean, and the mode. Those are kind of the best unbiased estimators. The other ones, they all have little flukes and issues. And that's why statisticians and psychologists, we use the mean a lot. We use the mean a lot. All right, I hope that asked your question about the bias estimator, unbiased. Amika, did I confuse you or did that kind of help?
I mean, it was a little confusing until we did like the example, but
Exactly.
I
All
feel
right.
like if I do more practice problems, I get it.
Yep. Okay, any other questions? All right, so I say we get on it. Let's get into the lecture. All right. Variation, this is a little aspect about this. This is preaching. This is when we get to the point of understanding statistics. Variation is the single most important concept to understand in statistics. The single most important concept to understand in statistics. When we start talking about the standard deviation, which is all about variation, this right here is the most important thing that you want to be able to understand in stats. Now, one of the things that we want to do, we want to talk about the 3 types of measures of variation. One is the range, which we're going to gloss over that pretty easily and pretty quickly. The other is the standard deviation, which is complex. We're going to try to do this by hand in class today. And I think I might put it up on the screen and see if you guys can recreate the table on a piece of paper and follow along with me. And then variance. Variance is kind of cheating because once we sit back and do the standard deviation, we're so there, we get to square the standard deviation, but it gives us a very different measure. It gives us a very different measure. Now, what I want y'all to do, if you can, look on page 97. Page 97, I think, goes back to the conversation of what we were saying before about bias estimator and unbiased estimator. I want us all to be able to look at that. So I think you can follow my screen. Let's see what's on page 97. Actually, hold on. That's not what I want to show you guys. So let me, okay, I don't see what I wanted to show y'all, so forget it. Let's go back to PowerPoint. These are the 3 measures of variation. We're going to go into them a little comfortable. I try to make you a little uncomfortable. We're going to go into them in great detail today. All right, so what is the range? Now, we had the example that we just did today, right? Now, we can go into greater detail by looking at the textbook for the example, but the range is very simple. We take the largest number and we subtract the smallest number from that. And that gives you range. It sits back there and lets you know that, all right, when we look at the population or the sample, it gives us the reach and I say the range, it's the whole definition, but I would say the reach of these data values and those scores. Now, some important properties about this. Remember I talked about before, some of these measures that we talk about appreciate every data value, others do not. The range does not. The range does not appreciate every data value in here. If you look at these airport data speeds, which is an example that's always in the textbook, they talk about, I guess somebody went to the airport and they did a little, what I was telling the peer, one of your friends to do today, was to sit back and to test your internet speed, right? Now, this person went to the airport and they were testing the Wi-Fi at the airport devices to see what the Wi-Fi speeds are really good at, and they're here. Now, to calculate the range, we have to figure out the maximum score. Out of this subset of scores, what is the highest Wi-Fi speed that we have on the screen? Uh-oh, I'm assuming y'all mics are muted.
55 points.
I heard 55.6, right? Now, what is the minimum? What is the lowest score?
14.1.
All right, so very simple. Again, the range isn't anything complex. We're going to sit back there and calculate the range. What is the range that you guys have? You guys do it yourself? What's the range?
41.5.
41.5. That means when you go across the country But when you go across these different airports, when you're sitting back there, you have a connecting flight and you try to use their free courtesy Wi-Fi, that is a big range. Let me tell you, some people don't even have upload and download speeds of 41.5 megabytes per second. Some people don't even have that fast internet, period. And yet we have other individuals who, across this aspect, that's the variability that we have, the variability in scores. I think a good healthy download speed is about 25 megabytes. Although if you're paying, you probably want to get somewhere around $50, 50 megabytes per second. But anywhere between 25 is a healthy aspect. And I think I found out a little bit of research, it supports Zoom. That's what supports. I got you, Stone. I got you. All right. Let's move on to the next aspect. Standard deviation. Now I want someone to read this for me. Because this right here is one of these measures, and I like to hear in people's voices how they read these definitions. I probably shouldn't say this, but I like how people will read a definition and you could almost tell they reading the words, but they don't really know what it means. But I'm going to ask a lot of you guys to read this stuff over here. We're going to talk about it. Any volunteers, even though I probably set it up as like the worst setup of reading and volunteering?
I can do it.
All right, who's that?
All right.
All right, go ahead.
Standard deviation is a measure of how much the data values deviate away from the mean.
All right. A measure of how much the data values deviate away from the mean. Now, you know what? I want to show you this because what does it mean for data values to deviate away from the mean? I'm going back to the spreadsheet that we had before, right? This right here is, first we had the sum, but now we're going to do the average. The average of these scores that we picked, the letters in our name, is 6.625. Now, does anybody remember the rounding rule that we're supposed to use when we're rounding measures of center? Does anybody remember? How are we supposed to round these data values? Uh-oh, I'm worried. No one's saying it's on the screen now. But what you always say you should do is you should round to one additional decimal point from what the data has. So 6, 5, 6 letters, 7 letters. When we calculate the mean, which is a measure of center, we're going to report that mean as 6.6. Now, if you remember, when I calculated, it was actually 6.625. I don't want to go that far. When you tell me about the mean of the number of letters in people's name, tell me one decimal point beyond what the actual letters are. That's just a good rule of thumb. Now, when we sit back and think about what the standard deviation is, somebody else can repeat what was on this screen and now reset to us. What is the definition of the standard deviation?
You want us to read it again?
Yep.
Is a measure of how much the data values deviate away from the mean.
How much the data values deviate from the mean. So I'm going to show you what it means by deviating away from the mean. Our mean is 6.6. 6 deviates from that cell by negative 0.6. So I can do that math. 5 deviates from 6. How much? Y'all know? 6.6. You know, this is what I'm going to do. I'm going to let y'all type it in the chat. So 6 deviates from the mean of 6.6 by negative 0.6. I want y'all to type in chat, how much does 5 deviate from the mean? Oh, my chat is not lighting up.
That's negative 6.6. So it's going to be negative.
All right, we're typing it in the chat. If we're talking, we're cheating from other people from critical thinking. All right. negative 1.6 or 1.6, right? But again, we're talking about the deviation. I'm not really talking about the sign symbol yet. The next one of 6, we've already done that before. So that should be about 0.6 as well. 7, y'all do it for 7 for me. How much does 7 deviate from the mean of 6.6? I'm going to wait. Thank you, Dewaya. Thank you, Naris. Goodman. All right, y'all here with me. Excellent. It deviates by 0.4. Now we got 5. How much is 5? 5 we already have, so I'm going to skip over that. 6 we already have. I'm going to skip over that too. And then I guess I got the longest name in the class. It's unbelievable, right? I deviate 4.4 units. That's how much I deviate from the mean. And then last we have 7, which we've already done before, so there's no reason doing that. Now, this is not the standard deviation, but I want you to be able to look at this definition of what it says a standard deviation is. Standard deviation says it's a measure of how much the data values deviate from the mean. That's what deviate away from the mean means. That's kind of weird, right? But the standard deviation, and you look at this, X is the values that we just did. We had 11 for my name, 6 for someone else's name, 5 for someone else's name. X bar is the mean. So look at this equation for standard deviation. The equation for standard deviation actually has this, it appreciates and calculates these deviations. And this little summation means that we're adding all the deviations up between them, right? Now, there's 2 ways to do the formula when it comes down to the standard deviation. One is this fancy formula right here. This fancy formula right here is very difficult. We're not going to go with formula 3.5. I probably wish I could cross it out. But what we will be doing in class, when you guys create this little handout, we will be using formula 3-4. We will be using formula 3-4. And yeah, we'll be doing that in a couple seconds. Now, a couple things about the standard deviation. If we calculate the standard deviation on a sample versus the standard deviation on the population, as you can see right here, our equation, our notation is different. Standard deviation from a sample is lowercase s. Standard deviation from a population is lowercase sigma. That means a lot. It really does mean a lot when it comes to statisticians. It means that you can look at a research paper, and when you see S, you know they're reporting on a sample. When you see lowercase sigma, oh, that's the standard deviation of all students at Cheney University. So it is key to understand that. Like, are we talking about a class, a subset of a class, or we're talking about the entire population? If somebody says that the psychology major GPA is lowercase sigma 2.7, that means that's all psychology majors. If you sit back and say the psychology club reported the psychology major GPA and they got S equals 2.6, that means the psychology club did a little survey. It could have been in one class, it could have been in multiple classes, but it's not what we got from the registrar. It's not every single student that is a psychology major. So knowing that S versus lowercase sigma means a lot. Now, remember we were talking about biased estimator and unbiased estimator, right? As a result of that, I've mentioned before, standard deviation is a biased estimator, but it's biased by a means that statisticians, they get all fancy and excited about this. They can predict it. And the way that they can predict and compensate for it is this. If you look at formula 3.4, when you're using S, the equation for the standard deviation looks like this, but the denominator is n minus 1. When we're doing the standard deviation for a population, the denominator is not n minus 1. The denominator is instead n, capital N. So I said, standard deviation is a biased estimator. When you calculate the standard deviation on a sample instead of the population, it's going to be a little off. But it's off in a predictable manner. And the way that a statistician can compensate for how it's off is we don't divide by n. We're going to divide by n minus 1. So when we do that, it can be a better estimator of the actual population standard deviation. So that's the reason why we have two slightly different versions. Now in this class, we will always use n minus 1, but I just share that to let you guys understand, to see the ties between why there's a capital N versus a lowercase n minus 1, and then also to understand the difference between a biased estimator and an unbiased estimator. It kind of brings all that stuff home when you think about it that way. Now, this might take me a second to get this up, but I want to show you guys something. And as soon as I get it up, I want you guys to start trying to recreate this on a piece of paper that's next to you. 3.2. All right. Now, I want you guys all to create a table. Now, I know if you're not on Excel, you probably can't draw a table like I'm drawing a table, but this is what I want your table to have. Your table needs to be kind of what I'm outlining right here. Draw a table that looks like this. We need 1 column, 2 columns, 3 columns in that first row. Then we're going to have a little title bar. And I want y'all to put a Z here, Z squared. This should put a Z minus Z bar. Right here, we'll do a Z minus Z bar, and we're going to square it. Now, if you want, you probably should do this C1, C2, C3, and then C4 right there. And then you don't necessarily need a table, but I do want you to write these equations. You want to write the sigma Z. That's where we're going to add up all the values of Z. Z bar, which is the mean of these values. We're going to do sigma Z squared, which means we'll take all the values of Z, we're going to square them, and then we're going to add those up. And we're going to do that here. I don't want you to freak out just yet. Then we're going to have sigma of Z minus Z bar. You can write that equation to the best of your ability. And then sigma Z minus Z bar squaring it. So this right here is really all the table we need. And then just write these out on a line. All right, now I don't want to leave anybody. So I would like you guys, I'm going to give you some time to do this. And when you're done, I want you guys to type a D in the chat, meaning you're done. All right, I'm getting some chats. Excellent. We better chill out. I ain't going nowhere. Okay, we got a good number of us. 1, 2, 3, 4, 5, 6. How many people are in here today? All right, so we're waiting for 2 more people. I'm gonna give y'all some time too. Ooh, let me make sure that I'm not waiting for people that's not here. Okay, we're good now. We're good now. All right, everybody. Now, I want to make sure that you guys can see what I'm trying to show you because you actually can't. Now, if you look at this example, it said that we're going to go get some data from page 98. Now, if you want to, you can go get this numbers, but these are the numbers that I'm talking about. The numbers that we are interested in are, annotate. Looking right here, the numbers that we're doing, where's that chart? 38.5. What's the next number? Somebody tell me.
55.
55.6. All right, I need somebody else.
22.4.
22.4. All right, somebody else, please.
14.1.
14.1. All right. And
23.1.
23.1. Excellent. Data values. I'm going to make these, I'll make them red so they'll stick out. Right. And I think this notation should stay even though I go from one screen to another. All right. So those are the data values, right? So that's where we get the data from. Yeah, numbers are still there. I want everyone to list these numbers into your chart that you created. Select. So essentially, you'll have your numbers listed in your chart. Ooh, that works so good. Just like that. That's easy. All right, now, same thing. We'll wait for y'all in chat because we're all doing this. If you guys have issues, you need to speak. This right here is the hardest thing that we're going to be doing for Unit 3, right? Go ahead.
We're putting the values in the Z column, right?
In the Z column, just like I have depicted on the screen, correct.
On the screen, all I see is numbers on the text.
All right, hold on.
Yeah.
Oh.
I wonder why you were saying it so perfect. I was like, no, it's not. It's over the.
Oh man, I lost it. I think when I moved from one screen to it, okay. All right. Who can tell me those numbers again?
38.5, 55.6, 22.4, 14.1, and 23.1.
Okay. You know, I knew that was too good to be true. All right, so it's looking just like this. I'm sorry. Thanks for letting me. Y'all can see it now, right?
Yes.
Okay. Now for Z squared, right? Actually, I'm looking at y'all faces. I'm trying to see if anybody you put in chat. All right. Now what y'all need to do, we got the values of Z. For Z is for the Verizon data, right? We're going to square every last one of those values. So to square, we're going to take 38.5 and we're going to square it. Now, if you don't have a fancy calculator, squaring is nothing more than that number multiplied by itself. So if you don't know how to do squaring on your calculator, what you can do is you can type in 38.5 times 38.5, and that's going to give you a value. Now, what I'm going to ask for is I'm going to ask for people to type in the chat the values that they've done, and we'll take the first person to do it for each of them. But for 38.5, I'll do the first one. 38.5, right? When I square that, the value I have, 38.5 times 38.5 equals, whew, it's a big number, 1482.25. I'm going to 2 decimal points because, like I said, that we're doing a measure of center. Measure of center has 38 point something. It's already at 1 decimal point. When we sit back and do a measure of center off of them, we're going to take it 1 more additional decimal point. So looking in the chat, I did 38.5 and I gave you the value of what it is when it's squared. I want us, everybody in this room needs to give me 1. Now, I guess you could cheat and duplicate. Nobody could do the first one. But sit back there, do the values just like this so we can see. And then you can check somebody else. I know somebody won't be like, nah, Wisdom, you did it wrong. I'm double checking her. You actually did it good. Good job. Mika, let me check her out. Excellent. 2 digits. That's beautiful. Jasmine, I see you the first one I see on 14.1. Excellent. All right, question. Now here's, I feel like we're talking over each other. Good job, Dewaya. All right, now is there anybody that doesn't know what we just did or can't follow it? Okay. I'm gonna do annotation again. I'm gonna do text. I'm gonna put these numbers, values in. Now, if y'all can give me the values in order, it'd be appreciated. 38.5, that's the one I did. What's the value for that when it's squared?
1,482.25.
All right, so you can't talk no more. That was you, Wisdom, right?
Oh, that was Jasmine.
Ooh, my bad, Jasmine. So Jasmine, you can't talk no more. Somebody else.
3,091.36.
That's Williford, right?
Yep.
All right, who's next? 22.4, what's that?
501.76.
501.76?
Yes.
22 times 4 times, hold on.
Listen.
Nah, you know what? It's just small. I don't know why it's so small. And I owe you an apology because it's right.
Am I the only one who got that one? Did I do it wrong?
You know what? Here's the issue. I'm trying to do the screen share, so I can't see chat to verify it. But I owe you an apology, Nyrese. It seemed like I offended you some kind of way. All right, 14.1. Who else?
198.80.
198.81.
81.
Excellent. And then 23.1 equals
533.61.
all right. I'm telling y'all what we're doing right now. This is challenging, right? Let me line them up so they're not going to be perfect, but y'all can see. All right. Now, we did this already with our letters and numbers in our name. We're going to take the individual scores of Z, which are this column right here, and we're going to subtract them by the mean of Z. First, we got to calculate the mean of Z. So let me go back and do that. This is so annoying. Text. Okay. Out of here and stop. And then go to Excel. It showed up. 58.5, 55.6, 22.4, 14.1. Now, y'all can do this by hand if you want to, but we're going to use technology. We're going to calculate the mean, which is the average. And just like magic, we have a mean of 30.74. 30.74. So this is what we need to do right now. We got to remember 30.74. That's an actual important number, right? I am going to go back here. Our mean, I'm going to write it here so it's for reference. 30.74. I'm going to put that right here. Okay, I don't know what's wrong.
We don't round it.
We did round it. Again, look at what we did. The original numbers are 1 decimal point. For a measure of center, we always have it 1 additional decimal point. So since our raw data is 1 decimal point, our measure of center will be 1 plus 1 additional. So that's why we stop here. We stopped at 30.74. Now, do you mean rounding like I did something wrong elsewhere? Let me look at this. Yeah, I think it's rounded appropriately. Now, this column, what we're going to do is this. We're going to take Z, which is 38.5. We're going to subtract it by 30.74, and we're going to put that value here. So same thing. I'm not going to do this. I want people to do that in chat. And everybody needs to give me 1. If everybody gives me 1, if we don't try to duplicate, we should have all of them done. But 38.5 subtracted by 30.74. And again, I don't want this to be a mystery, right? I want you to sit back and realize this equation is saying just that. Z minus Z bar, which is the mean. So that's 38.5 minus 30.74. That's the truth for this line. If I do this one, it would be 14.1, which is Z, minus the same mean of 30.74. If you guys can add those different values in the chat, that'd be greatly appreciated. All right, the first one we got from Dwyer. I'm gonna check your maths to make sure. I'll apologize already because I'm pretty sure you got it right. Now, Reese didn't like me checking her. All right, that's perfect. All right, wisdom. Now you know what? I think you're right. However, I think you wrote it in a weird way. You wrote it like I did the last one, right? Right. So if you could write it in there as like 55.6 minus 30.74, just be clear. But you got it right. I'm sure you got it. Same thing with Siani. I guess I should leave y'all alone. Y'all doing it right. It's just it's not how I would like it. But I ain't tell y'all to do it. I don't want to be a control freak. I'm gonna check y'all math though. Trying to get Siani. Hold on. Okay, she's good. Actually, hold on, Siani. You have negative 7.64. I don't have that. Let's look at this. 23.1 minus 30.74. Oh, no, you are right. I messed up the first time. Go ahead. I like that. I'm trying to get y'all, but y'all are doing really well. Do I have all values now? I don't think I do. And it surely is not 8 people participating. What? Telling y'all, it's easy to be lost in this class, and it usually happens from I'm too cool to participate. If you don't understand, unmute yourself. We can help you out.
I keep sending my answers to people privately. I'm so sorry, Latifa.
No, that's because you talking about me in the chat.
I've been doing the same thing. It's fine.
No, that's because y'all talking about me in the chat.
Yeah, I would. No, it's like when you click on the person's name before you try to scroll, it goes automatically to private message. And I was sending all my answers to Nerese.
I was wondering why I was getting stuff.
All right, I think y'all looking good. Excellent, guys. All right, so I'm gonna do the same thing. Let me do the notations, and we're gonna have somebody give these values so we can go through this really quickly. We got 15 minutes, and I want to make sure we get through all of them. All right, so for 38.5, when we take that and subtract it by 30.74, the value that we get is what?
7.76.
7.76. Now, it's positive or negative?
Positive.
Okay, perfect. I just want to make sure y'all give me the negative sign, because there's a trick that's going to happen after this column that it only works if we do it right. Okay, 55.6, when you subtract that from the mean, you get a value of what? Who can tell me? Wisdom?
Wait, can you repeat that? I'm sorry.
You know, I stole it from what you put in chat. Don't worry about it. All right. Nyrese,
Oh.
ask you, 22.4, when we subtract it from 30.7, the mean, we get a value of what?
Can you hear me? Okay.
Now I can.
Negative 8.34.
Okay. Deja, when we take 14.1 and we subtract it from the mean, what value do we get?
Negative 16.64.
All right. Who did the 23? Goodman. When we take 23.1 and we subtract it from the mean, what value do we get?
Negative 7.64.
Okay. Now, I told y'all I'm gonna show y'all a little neat trick, right? Let's see if I can get this to work. Okay. Now I'm gonna delete all this stuff that we have in here so it's not in our way, distracting us. I'm gonna take the values from this column right here. 7.76, 24.86, negative 8.34, negative 16.64, negative 7.64, negative 7.64. What I'm going to do is I'm going to calculate the average of these values. Now, I mentioned before, what we're essentially doing is this. We calculated the mean, and then we're looking at each score from this sample, and we're subtracting that score from the mean, right? But realize, we can't even calculate the mean without appreciating every value. There's a funny thing that happens when you add up the deviations from the mean. When you add up the deviations from the mean, we get a value of 0. And that's because, quite frankly, that's what the mean is. It's a measure that's talking about how these scores different, and we put it right down the middle in the average. We sit back and pick each score and see how each of these scores differ from the mean. By definition, they will all cancel and zero themselves out. So when we're on this handout, when we're on this handout, one of the things you can do is do what we say right here. R4 asks us to sum z minus z bar. These values, when we add them up, it should equal 0. If it doesn't equal 0, we messed up somewhere. That's why I was calling out Nyrese. I'm like, what, Nyrese? That value don't look right. Because if it was wrong, now she's right, I was wrong. But if it was right, if shit was wrong, when we did those values, like in this document right here, they would not total to 0. It would not total to 0. So that's a great step, but you got to know this handout. You got to pay attention to what we're doing right now to be able to identify that. All right, now I showed y'all a neat little technique, right? The next column is the same thing, z minus z bar, but it's squared. Now you might know how to do this on your calculator or not, but the best thing to do is to sit back and take 7.76, if you don't know how to be fancy, and multiply that by 7.76. Now, same thing, I'm gonna do the fancy technique that we do. I want people to sit back and do 7.76 in the chat, and then in parentheses, they'll give me what that value is. 7.76 times 7.76. And that value is 60.21. 218. Now, the reason why, the values that we have that we're using already are 2 decimal points. So we're going to take it to 1 more decimal point, which is 3. So again, please don't copy my value. I want everybody in here. It needs to be 8 different contributions. Don't send it to Nyrese. Send it to me. Everybody needs to give a contribution. And you can duplicate, but I want to see that you guys can calculate the square of the deviation from the mean. All right, Jasmine, let me double check yours. Now, the only thing you did wrong, Jasmine, and I'm gonna ask you to retype it again. You didn't take it to 3 decimal points. You didn't take it to 3 decimal points. Because again, our data has 2 decimal points right here. And when we do any type of measure of center, which is what, what we're doing, we need to make sure that we take it to 1 more additional decimal point. But your number is accurate. I see that. We both know that. Wisdom Jackson, same thing. Let's take it to 3 decimal points. All right, now Nyrese. Now I'm gonna show y'all. Let me go through an example right here. I think I'm glad we're doing this because I hope I'm not trying to make anyone feel embarrassed, but I want to sit back and show people how they appropriately round. And I don't think we're rounding appropriately right now. 16.64, right? And we're going to multiply that by 16.64. We're going to multiply them by each other. This times that. The value we get is 276.8896, right? Now that's what our calculator is going to show us. But now we got to put our own kind of thinking on here. Since it's at 2, we're going to go 1 more decimal point. We got to stop at 3. To successfully round this only at 3 decimal points. 889. So what we're going to look at, we're going to look at the 9. We got to look at the number after the 9. Does anybody know what the rule that we do?
If it's more than 5, you
9.
round up. Sorry.
Okay. You said, say it again.
5, you round up. 4 and below, you stay the
You
same.
leave it the same, right? So since it's a 6, we need to round up. Now, we can't, there's no number really after the 9. So our value will be this.
Okay.
Uh-oh, hold on.
So wisdom was right.
Wisdom was right? Yeah, but she didn't list that number. Hold on. Let's do 3 decimal points. It should look like this. That's how it should look.
Okay.
Yep. So again, it's tricky. It takes a lot of critical thinking. I just want to make sure that we know how to do it. Like, I used your example, but yeah, trust me, I think a lot of us need to look at this.
I'm
3 data points. Okay. So, all right, I think I'm going to go through all these numbers real quick. And I'm hoping I can get somebody. I might ask you, Wisdom, if you don't mind. I'm going to sit back and double check all these numbers. And I'm going to put the numbers appear on the screen. You can do me a favor and write down the values that are on the screen in this order. It'll be very helpful. Like right now, I'm typing in 7.76, and I have that squaring itself. So the number that we need first in chat is going to be 60.218. Uh-oh.
Wait, so you want me to type 60.218?
In chat, yep.
Okay.
Okay, now immediately following that, we're going to type in the next one, 24.86. You could type in 618.020. Type that in chat. 24.86. That's 618.020. Put that in chat, please. All right. Excellent. So then we'll do negative 8.34. 1 second. 1 second. Okay. So 8.34, somebody, actually wisdom, right? 69.556 in chat. All right. And then 276.890. And then last but not least, 58.370. All right, so that's going to help me. I can take this. And we're going to do the same thing. We're going to add these. And I know I just jumped without looking at the screen. I'm going to show you why. That's because going back, looking at this document right here, we put the values here, which are what we just got from Wisdom. Wisdom helped me write those. Annotate, text. Put those values right here. What we do here, move this out my way, we're going to sum that column. The sum, Chico, z minus z bar squared. That value we just figured out right here, and that's 1083.054. So let's go back here. The value here would be 1083. Text 1083.154. Hope that's what it was. 1083.154. All right, so that value's here. Let me double check just to make sure it's right. I might be 1 decimal point off. 054. Get out of here. All right. It's actually weird. There we go. Now, we have pretty much done the hard part for calculating a standard deviation. The reason why is this. I'm going to sit back and show you what this equation is. The equation that we have is S for the standard deviation is the square root of this sigma x minus x bar squared, which is what we calculated, which is what our 1083.054. So we'll take the square root of 1083.54 thousandths, and we're going to divide it by n minus 1. Now we have n, there are 5 data points in our data. So 5 minus 1 equals 4. So we're going to divide, do it right here, 1083.054, divide that by 4. And then we're going to get the square root of that. Now, the square root, you can do it with your fancy calculators. I think the way we do it in here is SQ, yes, square root. Of this value, 16.45.
Dr. Barnes, is it
Yes.
054 or 154?
It is 054.
Okay, I thought you said that.
I did say 1 point. I did say 1.5. That's because I'm going back between screens. I should have had a notepad.
Oh no, it's cool. It's cool.
Yeah. So the standard deviation, now think about this. We're going back to that definition, right? It's saying it's a measure of how the scores deviate from the mean. All what we just did is we calculated by hand how that measure operates. And it gives us a value of 16.454. 16.45 if we think about the original data. That will be our standard deviation. All right, now I'm going to clear all this off the screen, our little fancy annotation stuff. Clear all drawings and stop this. I believe we are pretty much done with what we're doing. This is the standard deviation. Yeah, we're not going to do the range rule of thumb. The one thing I'll leave is this. One is the homework. The thing that we didn't go into detail about is the variance, right? The variance is nothing more than taking the standard deviation and squaring that value. So if we were to go back and look at this value of 16.45489, if we square that, that gives us our variance. So again, knowing how to do the standard deviation by hand is really, really key. All right, that is all I have to say for that right now. We'll pick up if you guys have any questions or concerns later. Thanks for sticking in here. If you guys have any questions, you can either hang around, email me, or let me know. But that handout, and again, that's why I'm glad I recorded it. That handout will be, it's available online, and there'll also be a version for y'all to print if you want to on D2L. But that same technique is what I'm going to ask you guys to do for one of the homework problems for 3.2. All right, people, that's it. Thank you for giving me 3 more minutes. Y'all have a good